Hello. In this video, I will present you my term project for EE512 Microwave Electronics course, for which we were asked to design an RF amplifier board which provides 10 dB amplification for the wide frequency range of 1.5 to 2 GHz. Throughout the video, I will explain design steps I took which led to the actual implementation of the board, and then I will proceed to presenting you my results. The project requirements for the RF amplifier board is listed below. The project consists of three parts. In the first part, we are asked to design the schematic for the board, and in the second part, we are asked to make a layout design, and in the third, we are asked to make actual measurements on the board we designed and compare them with simulations. In the first part, I started by biasing my BJT transistor with 12 volts, and the operating point I chose is 8 volts 50 milliamperes. The design you see on the right also ensures low beta dependence, and then I stabilized the transistor using a stabilization resistor and a capacitor. This is the schematic for my amplifier design. Through the ports, the input and output matching networks are all to be connected. Final operating point after stabilization and DC biasing network design is 7.4 volts and 48.6 milliamperes with DC supply values of 12 volts and 51 milliamperes. The input and output matching networks are on the right of the screen, which use transmission lines, resistors, and capacitors to make matching between transistor and input ports and convert the impedances to 50 ohms. In the second part, I converted my nested schematic design to a single layer unnested design and changed transmission lines with microstrip lines, and I moved on to PCB layout design after layout simulations. This is the final schematic of my amplifier design, which consists of all networks I designed in the first part. And this is my layout design. In the third part, I mounted all components on the actual printed circuit board. And then I moved on to making measurements. These measurements consist of S parameters, 1 dB compression point, third order intercept point, and noise figure measurements. As for the S parameter measurements, I was able to compare their results with simulations I made in the previous parts. And here are my results. The DC biasing results slightly vary. The stability factor K for the actual board doesn't make problems, as it is always above 1 through a wide range of frequencies. The transducer gain is lower than expected, which I believe is caused by human errors such as soldering mistakes and possible measurement errors. The input return loss and output return loss are above 10 dB at some frequencies in the operation range, which may cause problems and need to be fixed before using the amplifier in an actual operation. And these are my nonlinearity and noise measurements, which consist of 1 dB compression point, third order intercept point measurements, as well as noise figure and temperature measurements over some frequencies. Thank you for watching.